Have you ever dreamt of exploring the farthest reaches of the universe in the blink of an eye at a speed faster than light? Traveling beyond the speed of light has been a staple for science fiction, inspiring the likes of Star Wars and Star Trek. But is it really possible? As we know, the speed of light is an absolute barrier. It's the cosmic speed limit, and nothing we know of can travel faster than that, because it would require an infinite amount of energy to do so. But what if we could warp the fabric of space-time itself? That's where the Alcubierre warp drive comes in. It proposes a workaround, a jugaad that would allow an object to move faster than the speed of light without violating the laws of physics. And how exactly? Let's find out. My name is Siddharth and you're watching The World of Science.
Because technically you cannot go faster than the speed of light, but space can travel faster than the speed of light. That's what's meant by warp drive. The amount of energy you need to warp space is unbelievably gigantic.
The concept of warp drive was first imagined by science fiction author John Campbell way back in 1931 in his novel Islands of Space. However, it wasn't until 1990s that physicist Miguel Alcubierre proposed a real-world method of achieving faster-than-light travel. This concept was based on the works of Kip Thorne and his research on wormholes and time travel. However, while wormholes remain completely theoretical, the Alcubierre warp drive is based on established laws of physics. So, how does it work? The key to warp drive is in fact in its name. According to Einstein's theory of relativity, space-time can be warped by gravity, and that is the reason why planets and stars are attracted to each other. The Alcubierre warp drive takes this idea a step further by suggesting that instead of propelling the spaceship at the speed of light, we can warp the space around the spaceship, thus connecting two distant points in space and covering the distance at normal speed. The Alcubierre warp drive would work by creating a bubble of space-time around the spacecraft. This bubble would contract the space in front of the spacecraft and expand the space behind it, thus allowing the spacecraft to ride a wave of space-time. It's like surfing, but on a cosmic scale, allowing it to travel at a speed faster than light without actually breaking the cosmic limit. See, the spaceship isn't moving at the speed of light, but the space around it is, which means it can cover vast distances in a relatively short amount of time. In the Star Trek franchise, the concept of warp drive has been explored in great detail. They even came up with the term warp factor, which denotes the magnitude of the warp field around the spaceship, and the value of the warp factor would mean the speed that has been achieved. For example, warp factor 1 would mean breaking the light speed barrier, and warp factor 2 would mean 8 times the speed of light, and so on. To generate enough energy for the propulsion of the ship and warping the space around it, the spaceship has a warp core, similar to the core that we have in a nuclear reactor. But in this warp core, matter and antimatter are allowed to collide at high speeds to produce a huge amount of energy. Until the 1990s, this warp drive was just a fictional concept. But in 1994, Mexican physicist Miguel Alcubierre proposed a solution to the shortcoming in the Einstein's field equation that uses a similar approach to the Star Trek warp drive. He suggested that faster than light travel is possible only if the energy density requirement around the spaceship is lower than that of vacuum energy, that is, negative energy density. Positive matter generates positive pressure and gravitational field which attracts other matter according to the universal law of gravitation. But this negative energy density produces an anti-gravity effect that is used to push the space around the spaceship. And using a definite arrangement of negative energy field, space around the spaceship can be curved to form a bubble of space-time. Rather than increasing the speed of the spaceship, the warp drive will contract the space in front of the spaceship and expand the space behind it. The ship will be enclosed inside a bubble of forward contracting and backward expanding space. Now that space can move at any particular speed, using negative energy density, the warp drive can increase the speed of contraction and expansion eventually to achieve faster than light travel. Remember, it is not the spaceship that is moving towards the destination, but the destination that is moving towards the spaceship at the speed of light. Of course, this is all still very theoretical. The amount of energy required to create a space-time bubble is currently beyond our capabilities. It would in fact require energy equivalent of the mass of Jupiter just to get a tiny spacecraft moving at warp speed. All of this seems too good to be true. There must be some downsides, right? For example, the space-time bubble could potentially create dangerous levels of radiation as it travels through space. Or there's always a risk of the bubble collapsing, which could lead to the destruction of the spacecraft and the crew along with it. NASA has been studying the Alcubierre warp drive for some time now, and the US Defense Intelligence Agency has announced in 2018 that they were exploring methods of faster-than-light travel, with warp drive being one of them. Recent reports suggest that models based on the Alcubierre drive are being developed, raising the possibility of interstellar travel in the future. And while we may not have the technology to develop a functioning warp drive yet, the fact that it is being taken seriously and studied by scientists is pretty exciting. So, could faster than light travel become a reality? Who knows? Perhaps an alien civilization in a far-off galaxy is cruising through space and time using the same technology. And even if we're never able to figure out how to make it a reality, it's still fun to dream. So, did you enjoy this video? Let us know in the comments. Make sure you subscribe to the World of Science. Until next time, stay scientific.